Math 31, welcome to example 4. We're going to restrict the domain and then find the inverse of this function, the square root of 2x plus 3. So first thing I see is my spidey senses go off a little bit. I'm going to have a domain issue because I do have an even index. So I need to make sure this radicand is positive. And we'll address that, but I also would like to just graph this initially. And this is basically one of our toolkit functions, right? We know the square root of x basically starts at the origin and moves out. Now things have been stretched and shifted a bit, but let's just graph it. Get a feel for what this looks like. So there's my function. It is a function, it passes the vertical line test and it passes the horizontal line test. So f inverse of x is going to exist. That's the first thing I'm gonna just mention, right? So this function passes the vertical line test and the horizontal line test, which tells me f inverse of x exists. And I'll find it in just a moment, but for now, let's just talk about what the domain and the range of our original function would be. So in terms of domain, luckily my radicand is just a linear expression, so I can solve this. I can move the 3 over, right? If I need that radicand to be positive or 0, and then I can divide by 2. So x has got to be greater than or equal to -3/2. So when I'm talking about my original function, I know the domain will start at -3/2 and go all the way to the right, go all the way to infinity. And I saw that happening in my graph. Right, it looks, I guess I'm starting at -1.5 or -3/2, and you can see my function goes all the way to the right. And then I can also see the range here. It's starting down here at, I'm guessing not the origin, but at y equaling 0. I'll check that in a moment. And then it goes all the way up. So let me plug in -3/2 and just verify that that y value is 0. And it is. So my range is going to be 0 to infinity. And I do this, especially when I'm dealing with inverse functions, just because it grounds me. It helps me remember, okay, that means when I go to find this inverse function, whatever it's going to be, I know its domain is going to be 0 to infinity, and its range is going to be from -3/2 to infinity. So that's why, at least when I go through these problems, before I even get to swapping out x and y and solving for my new y variable, I like to find the domain and range of my original function, because it gets me centered, and I know, okay, the domain and range of my inverse are going to be the flip-flop of the original. And when I say flip-flop, again, domain becomes range, range becomes domain. All right, so with that, once I've got that situated, I actually am going to go through and we're going to find this inverse function. Now, the first step in finding an inverse function is replacing x with y and y with x. And keep in mind, even though this says f of x, that is our y notation. So I have y equaling the square root of 2x plus 3. Okay, so the first thing I need to do is swap out x and y. All right, and the next thing I'm going to want to do is solve for my new y variable. And if I want to solve for my new y variable, I'm going to square both sides. And for me, I'm going to write the y variable on the left side. I personally like the variable I'm solving for to be on the left side. Now let's solve for y. I'm going to have 2y equaling x squared minus 3. All right, and then I'm going to have y equaling x squared minus 3 over 2. All right, so I've got that solved for. Let me just move over here a little. Now, you can write this in a couple of ways. You could write it as x squared minus 3 over 2. I'm fine with that. You can say this is x squared over 2 minus 3/2. You could say this is 1/2 x squared minus 3/2. Let's see, is there another way to write it? You could write this as 1/2 times x squared minus 3. There are a bunch of ways to write this. You find the form that works best for you. I think I'm going to roll with this one. So once I've found that, my third step is to say f inverse of x is equal to 1/2 x squared minus 3/2. And if I were to leave my answer like this, I'm gonna be a little wrong. So we wanna be careful. And you might be thinking, well, like, why is this wrong? Well, let me show you. If we go over to our graph, I wanna just type in this inverse function. So let's do 1/2, I'm gonna put it as a decimal, x squared minus, and 3/2 as a decimal is 1.5. If you wanna write them as fractions, great. I'm lazy, I feel like doing it that way. If I graph that, you can see that this is not a reflection. These two graphs are not mirror images of each other over the line y equals x. I have too much there, right? Take a look. This piece over here is not what I wanted. I like the fact that this piece and this piece look like reflections of each other, but this thing over here is unnecessary. And that goes back to what I was originally saying, in that the range of your original function will become the domain of your inverse function. So my inverse function is this function as long as x is between 0 and infinity. And if you haven't seen this symbol before, this means element of. It's a way of restricting the domain. So I will take this parabola as long as we only have the right half, the right piece of it. And if I head back to piecewise notation, if I wanted to do a piecewise function on my calculator, I will put parentheses, oops, let me put the decimal back in. I will put parentheses around that binomial. And then in another set of parentheses, I will put my restricted domain of 0 to infinity. So let me write x. And to get to the greater than or equal to, remember you need your test key, but you need the blue version. So I'll hit second in math. And then I'm gonna go down to greater than or equal to 0. And now that I've restricted my domain, if I hit graph, we're gonna see there's my original function. Here comes its mirror image, right? There's its inverse function, and that does get split right along that line of y equaling x. So these two are inverse functions of one another. So we just wanna make sure we're careful with restricting the domain when we need to, all right? So with that, we're gonna try one with a rational function. All right, I'll see you in a bit. Bye.